Hello, this is a little review video for factoring difference of squares. So the form of something that can be factored into difference of squares is a binomial that is a difference or subtraction of two perfect squares. And when you factor, you take the square root of your two numbers, and in your two parentheses, one will have a plus and one will have a minus. So for example, suppose we have x squared minus 9, and we want to factor that. So we want to think about that these are both perfect squares, and the square root of x squared is just x, and the square root of 9 is 3. And so into the parentheses goes the x and the 3, and one has a plus and one has a minus. Let's try another one. X squared minus 81. So the square root of x squared is x, square root of 81 is 9, so those are both perfect squares. The x and the 9 go into the parentheses. One has a plus, one has a minus. It doesn't matter about the order. You could do the minus first and then the plus. How about x squared plus 25? So those are both perfect squares. The square root of x squared is x, the square root of 25 is 5. However, it's not a difference, and it has to be a difference for this to work. It has to be a subtraction. So this one can't factor. Sometimes you have a coefficient in front of your variable, and so everything needs to be a perfect square for this to work out. And 4 is, the square root of 4 is 2, square root of x squared is x, square root of 9 is 3. So that's going to factor into 2x plus 3 and 2x minus 3. We can even have another variable. For example, if we had 25x squared minus 64y squared. We still have everything as a perfect square. We still have our difference, our subtraction. Square roots would be 5x and 8y. So that would factor into 5x plus 8y, 5x minus 8y. The next one is 3x squared minus 27. So when you look at this one, 3 is not a perfect square. 27 is not a perfect square, so it seems like it doesn't fit our formula. However, for all factoring, we want to check for a greatest common factor first. Every factoring problem we come across, we have to look at all of our terms and see if there's something in common that we could divide out. 3 and 27 both divide by 3. So we can divide a 3 out, put it out front, and then we're dividing it out of each term. So when I divide out of the first term, I'm just left with an x squared minus 27 divided by 3 is 9. And with all factoring, after you write down a step, you may or may not be done. You have to go through your list of all the different kinds of factoring and see if what you have left meets any of those. Inside the parentheses, we have a difference of squares. The square root of x squared is x, square root of 9 is 3. So this 3 out front will just stay sitting out front, and then the difference of squares, x plus 3, x minus 3. So we always have to check for a greatest common factor. That's especially important in this next one. 4x squared minus 16. So when you just look at that, it looks like it's ready to go. You have perfect squares, and it's a difference. 4 and 16 are perfect squares. However, it's not correct. It's not correctly factored until you take out the greatest common factor at the very beginning. And 4 and 16 both divide by 4. So before you start, before you do difference of squares, for it to be correct, you have to take that 4 out first. So I'm dividing out 4. And then I have x squared minus 4. Now what you have left in parentheses may or may not go farther, but this time it does because we have another difference of squares. The square root of x squared is x. The square root of 4 is 2. This 4 out front just sits out front, and it's 4 times x minus 2, x plus 2. So those are all just plain factoring. If you remember also during the quadratics unit, we solved equations by factoring. And so the difference was our original problem, where this is just 4x squared minus 16 and it doesn't equal anything. We're not trying to figure out what x equals. If we take our problem and it's set equal to 0, for example, x squared minus 36 equals 0, and the instructions are solve by factoring. Now not only are we going to factor, we want to know what x equals. So this again, perfect squares, difference of squares. The square root of x squared is x, square root of 36 is 6. But we have this equals 0. So when we factor, we're not finished after we have it factored. It still equals 0, and then once it's factored, remember you set each factor, each parentheses, equal to 0 and solve those. So we add 6, and x equals 6, we subtract, and x equals negative 6. We have two answers because it's a quadratic, it's a squared. Let's do one more solve by factoring. X squared equals 49. Now you did learn to solve by square roots, and you could solve this by taking the square root of both sides, but if the instructions are solved by factoring, you need to set it equal to 0, which is what we have to do for most quadratic equations. So if we want to minus the 49, now once it's set equal to 0, we're ready to factor. It's a difference of squares. Square root of x squared is x, square root of 49 is 7. And then set each term equal to 0. Add the 7 and subtract the 7. So that's our review of solving quadratic equations by difference of squares.